All right, let's get right into it. We've all seen the textbook version of how a project is supposed to work, right? You've got this perfect plan, a super clear schedule, and everything just flows. But today, we're going way beyond that blueprint. We're going to uncover the messy, human, and kind of chaotic reality of how great engineering projects actually get finished.
And this is the million-dollar question, isn't it? I mean, you've got the budget, you've got the smart people, the Gantt charts are beautiful, and yet things still manage to fly off the rails. Well, the reason, and this is what we're going to dig into, is that the plan is never the project. And really getting that distinction, that's everything.
So, first things first, we have to tear down this whole idea of a perfect plan. This first section is all about deconstructing that myth and really looking at what a plan is and what it isn't. And his quote it absolutely nails it. A project plan isn't some prophecy handed down from on high. It's a starting point. Think of it like a hypothesis about the future. Its real value isn't that it's flawless, because it never is, but in the shared understanding it forces a team to create. I mean, just take a quick look at this list, and this is just a partial list of what goes into one of these plans. Staffing, security, IP, budgets, certifications, it's this huge, tangled web of things that all depend on each other. It's pretty much guaranteed that something in here is going to change. No single document on Earth can perfectly predict a reality that's this complicated. Now here's where it gets really interesting. You have to understand your deadlines. Confusing these three types of dates is a classic recipe for total disaster. A hard date, like a planetary alignment for a space probe, that's non-negotiable. You miss it, the project is toast. But a subjective date, something dreamed up by marketing, well, that's where you have some wiggle room, where you can take smart risks. The key is knowing which kind you're actually up against. And let's be super clear about this, the project plan is not the design document. They're two totally different beasts. A project plan might say you have to use a certain processor because of some business deal. The design document is where the engineers have to figure out how to make that decision, actually work. And this is a huge deal because it means a lot of what look like technical problems are actually business decisions in disguise. Okay, so if the plan is always going to be flawed, what's left? What really makes a project succeed? Well, it's the people. So let's dive into this next section, the personality puzzle. It's all about who you really need on your team to handle all that chaos. I know, this sounds like a bit of an exaggeration, but it's really not. Having incredible technical skills, that's just the price of admission. What makes an engineer truly valuable is a personality that lets them use those skills in a way that's constructive, that's collaborative, and that's just relentless. Without the right mindset, a genius-level engineer can actually do more harm than good. So, who do you want on your team? You've got the traditional team player, which, let's be honest, is often just a nice way of saying someone is manageable and waits to be told what to do. But if you want to move fast, you need team leaders. These are the people who don't wait for permission. They attack problems, they hunt down information, and they push for results, even if it ruffles some feathers along the way. Get a team full of those people, and you've got an unstoppable force. And that brings us to this, the unlikely hero of so many successful projects, the passionate malcontent. This is the person who is just never, ever satisfied with good enough. They're stubborn, they're tenacious, because they are driven by this deep need for excellence. They're the ones who see the flaws everyone else misses, they question everything, and they push the whole team to build something truly great, not just something that gets out the door. It's a beautiful quote, right? Really inspirational. It's all about the power of optimism, about pushing forward into the unknown. In a lot of areas of life, that is 100% true. But in engineering, well, a starship built on pure optimism would never even leave the launch pad. For an engineer, pessimism isn't a personality flaw. It's a professional requirement. Your whole job is to think of every single way something could fail. You have to distrust assumptions. You have to plan for disaster. Optimism gives you the vision, sure, but it's a healthy dose of professional pessimism that makes sure the thing actually works without, blowing up. Okay, so you've got a decent plan, you've got a great team of passionate pessimists, you're all set, right? Ha, not even close. Now you have to learn how to navigate the corporate minefield. We're talking politics, conflicting goals, the fun stuff.
Welcome to the blame game. You know it, I know it. In any big company, the instinct for self-preservation is powerful. As soon as a schedule starts to slip, the finger-pointing begins.
And if you're an engineer just trying to do your job, you can get caught in some serious career-ending traps. The goal isn't just to do good work, it's to avoid becoming collateral damage.
Here is a perfect textbook example of a no-win situation. Your manager's project is late. They ask you to do a quick phone interview for someone they've basically already hired. Now think about it. If you say no, you're the bad guy delaying the project. If you say yes and that person doesn't work out, well, you share the blame because you signed off on them. It's a trap, and sometimes the only winning move is not to play. And these politics aren't always personal. Sometimes they're just built into the system. Just look at the classic battle between hardware and software teams. The hardware team's job is to keep costs down, which means slower CPUs, less memory. The software team's job is to maximize performance, which means they want the fastest CPU and all the memory. See the problem? These goals are in direct conflict. Without constant, brutally honest communication, you're guaranteed to have friction and delays. So we've wrestled with a plan, we've assembled the right team, we've dodged the political landmines. The design is finally signed off. From here on out, it's just building it. Everything should work perfectly, right? Yeah, of course not. This is where the real work actually begins. And that brings us to our final section, taking that design from a piece of paper and turning it into a real product that people can use. And it's all about the mindset you need to survive that journey. First up, we need to be crystal clear on what a good design even is. It is not some doodles on a whiteboard or some high-level theory. A good design is a concrete, actionable blueprint. It spells out what to build and how to build it so precisely that there are no big question marks left. It's the absolute foundation you need before you write a single line of code. Okay, now check this out, because this is where reality just completely demolishes conventional wisdom. Common sense says you want more performance, you buy a faster hard drive, right? Well, this data shows that a faster drive might give you a 20x boost. But the software and the file system you choose, that can have a 400 times impact. That is insane. The point is, what seems obvious to the business is often completely wrong from an engineering perspective. And this, right here, this is the true craft of an engineer. Debugging. It's not just randomly changing stuff until a bug goes away. It is a methodical process. A real engineer hates an unexpected result, even a good one, because it means they don't fully understand their own system. They trace the logic, they find the exact root cause, and they fix that. Just making a symptom disappear without understanding why, that is the ultimate engineering sin. So we'll end with this question for you to think about. A plan is just a starting point, because reality is always, always chaotic. So is the greatest value of an engineer really in just following the plan? Or is it in their ability to master all the chaos that isn't on the plan? The bugs, the politics, the bad assumptions, and still, somehow, deliver something amazing. That kind of mastery, well, you're never going to find that in a blueprint.